Hello students, good morning. In today's video, let us discuss about important short answer questions of chapter 7, System of Particles. In that the first question, define vector product. Explain the properties of vector product with two examples. So first, you have to define vector product. As I said, everything carries marks, even the definition, diagram. Through definition, through diagram, if you attempt minimum also, you will get the marks. So first, let us define vector product. So the vector product of two vectors you assume as A and B, right? You assume as A and B of two vectors. Let us assume that there is an angle theta between A and B. Okay, angle theta between them is A cross B is equal to, we will write as magnitude A, B sine theta with n cap as unit vector. Alright. So the vector product of two vectors A and B with angle theta between them is A cross B equal to AB sine theta into n, where n is the unit vector, where n cap is unit vector. Alright. Now next let us discuss about the properties of vector product. The first property is it does not obey commutative law. That is, A cross B is not equal to B cross A. It does not obey commutative law. Second one, it obeys distributive law. What is distributive law? In mathematics you have learned, no? It obeys distributive law. What is distributive law? A cross B plus C is equal to A cross B plus A cross C. It obeys distributive law. Now third one, if vector product of two parallel vectors is null vector, we can say, or the next property is vector product of two parallel vectors is null vector, that is 0. Parallel vectors means I cross I, J cross J, K cross K. The parallel vectors, they are equal to 0. Now next, if vector product of two perpendicular unit vectors is unit normal vector, vector product of two perpendicular unit vectors is unit normal vector. Now see, I, J, K, how we will draw? So what does this unit vectors I, J, K indicates? The directions. Okay, they indicate the direction of a vector. And these three are mutually perpendicular to each other. Now if I take, for example, if I take the vector product of two perpendicular unit vectors, I said. So, for example, if I take ij, they are perpendicular to each other, no? These two are perpendicular to each other, no? What he is saying, these perpendicular vectors, the vector product of these two perpendicular vectors comes out to be a normal vector of that. Normal means another perpendicular. What is another perpendicular to these two perpendicular? K. So it will be K. Now, if these two are perpendicular, the answer will be the third perpendicular one. Remember in such a way. Similarly, J cross K. J cross K. The third perpendicular for them, I. Similarly, K cross I. Just I am coming in this rotation. Easy to the trick to remember. I cross J. J cross K. K cross I. So it will be very easy while doing the problems either in physics or mathematics. Both are useful for you. Okay. Now next reverse of this we will get in negative signs. Such as now I cross J equal to K, no? Now J cross I is equal to minus K. K cross J is equal to minus I. And I cross K equal to minus J. In such a the reverse with minus. First three is enough to write in the exam. So in such a rotation we came. I cross J equal to K. J cross K equal to I. K cross I equal to J. Anti-clockwise direction. Alright. Now next, these are the four properties. Parallel, the vector product of parallel vectors 0, perpendicular vectors are, the third perpendicular vector comes out its answer. And it does not obey commutative law, it obeys distributive law. Now next what he asked, any two examples he said to give. Let us give. The first example, can you guess? Easy, torque. Tau is equal to R cross F. Now next, velocity. Linear velocity is equal to angular velocity cross R. Okay. So this is all about the vector product. If you like my video, share it, subscribe it. Thank you.